Good morning all, this is Srividya, Assistant Professor, Department of CSIT. Today I am going to talk about dynamic memory allocation in C. In the last session we have seen static memory allocation, what is the disadvantage with static memory allocation and what is the advantage of dynamic memory allocation and the functions of DMA. We have discussed this one function, memory allocation, malloc, in dynamic memory allocation. So what is static memory allocation? Let's recall the last session. What is static memory allocation? Suppose if I declare like this, char a of 50. So this is what? Declaration. And it is a string declaration. Okay. So string is an array of characters. Suppose if I initialize the same thing, char a of 50 is equals to, in compile time, so here I have taken the string mlrit. So to save or to store these data in the memory, character takes 1 byte of data, means we need 8 bits to store the data. So here I am storing only 1, 2, 3, 4, 5 characters. So to store these 5 characters, I have taken or I have fixed the size of the memory as 50. 50 into 1. So 50 bytes were reserved for this string mlrit, and rest of the places or rest of the whatever the places we have taken here, all are wastage. So to reduce this wastage with static memory allocation, we have moved to the concept of dynamic memory allocation. So what is dynamic memory allocation? Memory is allocated only at the time of execution. So how that we have discussed using malloc function. So malloc is memory allocation. So only the memory will be allocated at the time of executions, and dynamic memory allocation is done from the heap section. And to access this one dynamic memory allocation, we need to use the pointers that I have told you, that is one of the application of the DMA. So this is your heap section. Heap is a large pool of memory. Suppose if I want, by using this function malloc of 5, so in this heap section it will allocate that one single block of large memory, and on success it will return the first byte address. If not, it will return null. On success, it will give you the first byte address. If not, it will give you the null, because pointer always returns the address. So this session we will see what is calloc. Calloc is contiguous memory allocation. Mainly it is used with arrays. The syntax of calloc: void pointer calloc of n comma size of the data type. So why it is void pointer? See, you are requesting to assign some memory in the heap section, but calloc or malloc will allocate the memory, but they don't have any idea what type of data the user is storing in the section or in the heap section. So after assigning the space there, so it will return the first byte address on success. So and it will be the void pointer. Later you have to typecast, because you know what type of data you are storing here. Suppose if I am storing only integer values 1, 2, 3, 4, 5. I know that I am storing integer values. So I will typecast it in pointer calloc of n comma size of int. See, the difference between malloc and calloc is malloc will allocate continuous block of one single large memory, whereas calloc allocates multiple blocks of memory, each of same size. Suppose this is of 5, 5 and 5. So like that it will allocate. It will allocate single block of multiple blocks of memory. So this is what the example: int pointer calloc of 10 comma size of int. So what is size of int? See, when compared with the configuration or 16-bit machines or 32-bit machines, sometimes integer will take 2 bytes. and sometimes integer will be 4 bytes. Depends on the machine you are using. So we are leaving this thing to the compiler itself. So if integer takes 2 bytes, 2 into 10, so 20 bytes of memory will be allocated. Suppose if integer takes 4 bytes, 4 into 10, so 40 bytes will be allocated. Okay, so no wastage of memory. So on success it will return the void pointer, and if not it will return the null. The name calloc stands for contiguous allocation. Malloc function allocates the memory and leaves the memory uninitialized, whereas the calloc function allocates the memory and initializes all bits to 0. Suppose if the memory is allocated by using the calloc in the heap section, by using the calloc function, if you need to allocate some memory dynamically in the heap section, malloc function, I am talking about malloc. So all the places where, because here in malloc function it allocates single block of contiguous memory. So here if the data was not initialized, so all the blocks were filled with garbage values, some random numbers. It will be filled with some garbage values. Whereas in the calloc function, so if you want to allocate the memory dynamically in the heap section through the calloc function, if the data was not initialized, if that block of single block, whatever here, multiple blocks of memory which was not initialized, calloc function allocates, that places will be filled with the zeros. So calloc function allocates the memory and initializes, it will initialize all the bit positions there to zeros. So this is another example. PTR is equals to float pointer. Suppose if I want to store in the memory, in the heap section, or to allocate memory dynamically in the heap section, so I want to store all the floating point values. So I am storing floating value. So to which data type you will typecast? So you know certainly. So you are storing float. The data type is float you are using. So you need to typecast to the float data type, because initially it will be the void pointer, because whatever the function you are using to allocate the memory, either malloc or calloc, it doesn't have any idea what type of data the user is storing. Just it will allocate the memory in the heap section dynamically, but it doesn't have any idea what type of data the user is storing in that section. So on success it will return void pointer. So void pointer means it will not associated to any type. So later you need to typecast the data, because you know what type of data you are storing. If I want to store integer values, I will typecast to int. If I want to store, if I am storing their floating values like this, so I will typecast to the float data type. So here like this you need to typecast. Take a variable, pointer variable, and typecast float pointer calloc of, see here they have taken 25. So means I want to store 25 values in the heap section, size of float. Suppose if I want to store characters in that heap section like this, by using calloc will allocate multiple blocks of memory. So here I want to store 4 characters. See now how can I write? So here what data type we will use? We are storing the character value, so we need to take the character data type. Okay. So on success it will return void pointer. On success it will return void pointer. But later you have to typecast. So which type of values we are storing, that you know, right? So we are storing characters. So typecast it to character data type. So char pointer calloc of, how many characters we have taken here? Only 4 characters. 4 comma size of char. So size of character data type, size of character is 1 byte. 1 byte. So 1 into 4 bytes. So to store 4 characters we need 4 bytes only, because character takes each character will take 1 byte to store the data. So to store the 4 characters, we have taken only, it will assign only 4 bytes of memory. So no memory wastage will be there in dynamic memory allocation. Because memory is we are allocating the memory through malloc and calloc functions are through dynamically it is allocating the memory. Next, this is the example program to read and print 1D array elements using malloc. So this is calloc function. By using calloc, last session we have seen how to read and print the array elements using malloc function. So same example here, we are writing this program by using the calloc function. So all this malloc, calloc, realloc, free, or they are dynamic memory allocation. So the functions of DMA are malloc, calloc, realloc and free. So all these 4 functions exist in stdlib.h header file. So we need to include that header file because we are using those functions. So earlier we are from starting itself we are using printf, scanf. So printf and scanf exist in stdio.h standard input output header file. So like that, malloc and calloc or the functions that comes under dynamic memory allocation, so they exist in stdlib.h header file. So we need a pointer variable because those functions we can access through pointers or dynamic memory allocation is done through pointers. So here we need to declare a pointer variable and we have taken 2 variables int n comma I. Enter the number of blocks. So what is the size of how many values you want to give it as the input. So enter the number of blocks, scanf %d comma address of n. So the syntax, so what kind of data I want to store? I am storing only integer values. So integer values. So on success calloc will allocate. So if the memory was allocated, so on success it will return void pointer. So you know what type of data you are storing. So you need to typecast that data. So whatever data type you have required. So here I have taken only integer values. So 10 and 20 are the integer values and I am asking only for the two blocks of memory. So here int pointer calloc of n comma size of int. Suppose here my n is 2. 2 into, suppose let us consider the size of int is 4. 2 into 4. So 8 bytes of memory will be reserved. So here for I is equals to 0, I less than n. What is the number of blocks we have requested for? Only 2. So 0 less than 2. I value is 0. 0 less than 2. Condition true. Control will now enter into the inside the loop. So for loop, inside the loop we have written scanf function. Why we have written the scanf function? So after allocating the memory in the heap section, we need to allocate, we need to give the input value. So here a. So what is it? What it is written here? A plus I. A plus I. What is A plus I? A plus I means A is called, it is a pointer variable. On success it will return the first byte address, means the base address. Base address, let's consider the base address as 1000. 1000 plus, how I am writing the interpretation here. So I, the value of I is initialized to 0. 0 into, so what it is? Size of the data type. So it is, the formula here it is base address plus number to be added into size of the data type. Let's consider the int size as 2 here. So 1000 plus 0 into 2, which is 0. 0 into 2 is 0, so 1000. So here in the location at 1000, the first byte address, so it is asking you to enter the value. So now I will enter 10, the first input which I have taken here. Next, I becomes 1. After here, still the control is in this for loop only. So now I becomes 1. 1 less than n value 2. We have taken number of blocks as 2 only. So 1 less than 2, condition true. Again now control will enter here. So A plus I. Base address is 1000. Base address is 1000 only. We have considered it as 1000. Plus I value is 1. 1 into size of the data type 2. 1000 plus 2. So it is 1002. So integer takes 2 bytes. So the starting address is 1000. So after 2 bytes, the next address or the data will be loaded here. It is 1002. So at 1002 location, it is asking you to enter the next value, which is 20. So now I have entered 20. Now I plus plus, I becomes now 2. 2 less than 2, condition false. Control will exit from this for loop. Now it will come here. 0 less than 2. N value is 2 only. Okay, 0 less than 2, condition true. Now control will enter inside the loop. So it is here we have written the printf statement, means whatever the values we have given as the input, that I want to print there. So printf %d comma, it is star of a plus I. So in the previous session I have discussed its pointer. So a is a pointer variable. So if I write like this, printf %d comma a, I'll get the address. Suppose in the printf statement I have written like this, printf %d comma pointer a, I'll get the value at that location. So the difference between star a and a is a stores the address of, because pointer stores the address of another variable, but star a, it will give you the value located at that particular location. So it is star a here in this case. A is again base address 1000 plus I value 0. 0 into number of bytes, size of the data type, it is 2. So here 1000, because 0 into 2 is 0. Star of 1000. What is 1000? 1000 is the address, and star of 1000 means you want to retrieve the value at this location. Value at this location is 10. So you got, so the output here we got 10. 10 will be printed. Next, I plus plus, I becomes 1. 1 less than 2, condition true. Star of, now I value is 1. 1000 plus 1 into 2, which is 1002. Star of 1002 means 1002 address, the value that is at the 1002 address location here is 20. So 10 and 20 will be printed on your screen. So like that you can allocate how many data values you can take. You can take n values 5, 10, 20, depends on your choice, depends on your data. This is one more example to print the sum of the array elements. So same here we have used here calloc function to allocate the memory dynamically in the heap section. So we have included two header files. I should include stdio.h because we have used printf and scanf, and one more function stdlib.h because we have taken this calloc function. Calloc function exists in stdlib.h header file. So main function int n comma I, and a pointer variable was declared because it is sum of array elements. So sum is initialized to 0. So enter number of elements, scanf %ld comma address of n. Suppose if I want to calculate sum of array elements for 5, here in this example in the screenshot I have taken 6. You can take 6, 7, anything. So let's take only 6. Int pointer calloc of 6 comma size of int. So 6 comma size of int means now what it will do in the heap section, 6 into, let's consider size of int is 2. So 12 bytes of memory will be allocated in the heap section. Next, if so we are checking whether if p equal to null means memory was allocated or not allocated. On success it will return the void pointer, if not it will return the null. So if p equal to null, memory is not allocated, so it was unable to allocate the memory dynamically in the heap section. Next, so enter the elements for I equals to 0, I less than n, I plus plus, scanf %ld comma p plus I. So same the last example I have discussed, p plus I, base address plus I value 0 into size of the data type, so 1000. At 1000 location it is asking you to enter your first value. So calloc means multiple blocks of memory will be allocated, each block will be allocated, multiple blocks of single memory. Next, at 1000 location it is asking you to enter the value. Next, I plus plus, I becomes 1. So I becomes 1, 1000 plus 1 into 2. 2 will be at 1002 location, 1000 plus 1 into 2. So it is 1002. So at 1002 location it is asking you to enter the value. Next, 1004, 3. Next location will be 1006, 4. Next location will be 1008, 5. So here I have taken only 5 values and we need to calculate the sum. So how you will calculate the sum? Sum is equals to sum plus, so sum value is initialized to 0 plus star of p plus I, 1000 plus 0. Let's consider here star of 1000, star value with, this is called the dereference operator. Okay, so 1000 location, the value existed at 1000 location is 1. So 0 plus 1, sum is 1 initially. So likewise it will calculate print the sum of array elements. So next, what is next function is realloc. So what is realloc? See, previously we have taken 5 integer values and we have allocated, it was malloc function or calloc. By using it was allocated the memory in the heap section dynamically. If you want to resize the memory, means I want to increase the size, or if I want to decrease the size, is it that possible? Yes. With the help of realloc function, it is possible to resize the memory. Syntax: void pointer realloc of void old pointer comma new size in pointer A. See here, we have taken the example to allocate the memory dynamically using this calloc function. So in pointer calloc of n comma size of int. After that, if I want to resize the memory, in pointer realloc of previous pointer, it is previous pointer is A, and 2 into, now I want to reduce the size, means I am decreasing the size of from 5 to 2. So 2 into size of the int. So what is the A here? A is the previously allocated pointer. Here in this case we have taken the example here A. So here we have taken 2 values. Okay, 2 values. So if I want to increase the size by using the realloc, yes, you can do by the realloc. Just write it 4 into size of int. So by using this realloc, you can either increase the size or you can decrease the size. So again, pointer variable was declared I, n1, n2 are the 2 variables. So n1 is for the first size. So scanf %ld comma address of n1, means it is, we have taken this one for the previous allocated memory. So we have allocated the memory by using the malloc function. In pointer malloc of n1 into size of int. Printf addresses of previously allocated memory. For I equals to 0, I less than n1 plus I plus plus I. Printf %lp, the format specifier we are using here, ptr plus I. So ptr plus I. So how many values we have taken? Here see the output, I have taken the size as 5. So the addresses were printed because we are just printing the address here, not the values. Now I want to resize the memory. So for that I have taken one more variable as n2. So again I will allocate the resize the memory. So ptr is equals to realloc of, what is the previously allocated pointer variable name? It is ptr only. Ptr comma the new size I want to mention. So it is n2 into size of int. Now my values n2 size will be only 2, means before it is 5, now I want to reduce it to 2. So for I is equals to 0, it is 0 less than 2. So we have got only the 2 address values. So like that you can resize your memory by using this function realloc. So that's all for this session. We have seen now in today's session calloc, and we have discussed what is static memory allocation, the functions of DMA, and in the next session we will see introduction to strings in C. That's all for this session. Thank you.